Hi, today we learn Uniswap v3 on Uniswap v3 book. From after this book Ivan Kuznetsov, and I show you how implement first milestone, first swap, and we see how we providing liquidity in Uniswap v3. First of all, you need to understand Uniswap v2. It's not so difficult. You must understand automatic market maker formula. X y equals to k constanta, and you must read this milestone and see these pictures, these beautiful graphics, but he choose as assets in pool Ethereum and USDC. We can use just token 0 and token 1. Okay, from beginning, which difference, what difference between Uniswap v2 and v3? Difference is concentrated liquidity. Difference is that user can provider liquidity can define lower and upper price for his assets which he put in the pool, and he can say that for example my 5000 USDC and 1 ETH will be in price between 4545 and 5500, and exactly in this price range we can use this liquidity. If price goes to upper or lower from this range, you cannot use liquidity for swap. Maybe someone other guy provide liquidity, but for this position it will be impossible. Okay. In book we have some another formulas, another equations. We can see that we define price in this way, and we use ticks. But in this video we don't go to the ticks, we don't touch them. Let's just goes to the liquidity and swapping. Okay, so let's pretend that we have graphic, and in our case you must know this information confusing. In book Ivan Kuznetsov show us Ethereum and USDC, and he said that price which he used is price X in terms Y, which means that if I have Ethereum here and USDC here, that then price will be Y divided by X. But you must know that in Uniswap v3 in production there is no specific of these assets. There is only token 0 and token 1. Token 1. And smart contract store this information in next way. We have Uniswap v3 pool here code, and I can show you how they store this information. They just compare address token 0 and token 1. If token 0, I think I can find this quickly, but not sure about this. Where we can restore this information? Maybe during add liquidity, yeah, and add liquidity we have in mint function. No. We have already created pool with this token, so we must go to the factory. Yeah, definitely. In factory, yeah, you can see this event. So pool created, we see token 0 and token 1 and fee. These three details, 3 component of calculating pool address. And where is comparison? Here, see, function create pool, and we have some token X and some token Y, and here we see comparison. So if token X lower than token Y, it will be token X, token Y. Else, in other way, we define token Y and token X. We return this information and create pool with this token 0 and token 1. So for what I say to you all this info, because in book you see this price in this way, but it means that price of token 0 in terms of token 1. So you need divide token 1 to token 0 and you receive price. But maybe in real pool token 0, which must be always at the x in lower, in horizontal line. Maybe token 0 will be USDC, I don't know, USDC, and Ethereum can be token 1. You must know this, and you don't must wondering why price of Ethereum maybe price from this pool will be not for example 2000. This price will be inverted. It's one detail. Okay, let's move to the book and let's create swap. So for example we don't name our tokens somehow, we just use token 0 and token 1. Yeah, so this reserves of these tokens in pool, and then we create a liquidity and define lower and upper prices. For example, let's take price current. It will be P current. P current will be 4. Why? Because we store in this pool liquidity in amounts 20k, 20,000, and here 5,000. Okay, so we store in this pool X, its reserves of this pool will be 5k, Y will be 20k. So current price will be 20 divided by 5, which equals to 4. Okay. Next, we can we must define lower and upper price. Let's create lower price point, which will be 2, yeah, and the upper price P upper will be 7. Okay. What will be next? Nice. We must calculate liquidity. So user put these assets to this position, and we must give him liquidity. Yeah. So how it's calculated? It's not same as Uniswap v2. You remember that liquidity from Uniswap v2 are square root from xy, and that's it. It's simple, yeah. But in our case, in Uniswap v3, we must calculate liquidity in two ways. We must calculate liquidity for this price range separately, and for this price range. We must calculate liquidity when price go upper. Price go upper when when our current price go to the left from P current, and if price go lower, it's when price go to right side to point P lower, yeah. So we must calculate this liquidity for these parts separately. Why? Because all this price range will contain liquidity only for token 1. If price go lower, this green part, it's liquidity token 1, because we put token 0 into pool, we withdraw token 1, and liquidity will calculated, we will define only from token 1. And in other way, if price go upper, we can see blue sector. This sector will need only token 0 for swapping, and we must calculate separately liquidity for this sector too. And then in Uniswap v3 they compare these two values and choose minimum. Why? Because they said that if we choose minimum liquidity, minimum value. So another value will already contain this liquidity. Let's just pretend. So liquidity 1 will be, for example, 210, and liquidity 2 will be, I don't know, like this, 190. We must choose liquidity 2. We must choose liquidity 2, this liquidity. We must cut, from this some part of tokens, and take from user liquidity in equals to the left and to the right. We must do that thing that liquidity must be equal, and after this we must recalculate amounts. For example, I want store in pool 5k and 20k, but in real pool it doesn't accept these values. After we calculate liquidity with these params, after we choose minimum liquidity from two values, we use this liquidity for recalculate amounts, and we take from user only amounts which will be acceptable and which create exactly this liquidity in these values, in this value. For example, 190. Okay, which formula we will use? We can see this in this book. So first of all, we need calculate square root from price. It's use for further formulas, and in this type Uniswap E3 store this information in smart contract, so we can do this. It's not problem for us. So square root from price current will be 2, price lower will be 1.414, and square root from price upper will be 2.645. It's rounded values, don't mention about fractional sum. Parts is just for our understanding how it works. Okay, so next we can use these formulas of liquidity. You can see we have formula for calculating liquidity calculation. We can say that delta square root price will be equal to delta y and dividing by liquidity. Dividing by liquidity. Okay. Okay, and next formula we have delta 1 divided by square root price equals to delta x na liquidity. From these formulas next we can see these formulas for liquidity. We use this in you can see this information in book 2. It's simple. Compare with Uniswap v2. Here we say that price can be defined by user, and and you must understand that price position can contain only one asset, so another asset can be withdrawn full, so position can be depleted, pool position can be depleted or exhausted in from one asset or another. In Uniswap v2 it will it was being possible, but here we can go to this situation when y can be 0 or x can be 0, so position will be contain only liquidity for buying x or for buying y, and we can see these formulas for delta x, delta y. Here you go, and final formula for calculating liquidity is here. First and second formula. So we use this formula. In book we can see that delta x and delta y we use. In our case, delta is equals to how many assets we put, so we can say that our case token 0 delta x will be 5k, 5,000, and y will be 20,000. So we use this formula for calculate liquidity. Okay, I do this already here, and we can see that 5,000 we calculate liquidity 1, it will be 41,000. You can see how how I calculate this. Yeah, so 5 it x delta x in our case, and then 2.645 it will be price lower or upper. Sorry, I must remember this. Yeah, but in book we have some confuse about points of upper and lower points, because graphic we have PA, it's lower, yeah, lower. So in this case, when we calculate liquidity for first, it will calculate liquidity for x. We have upper square root, yeah, here we can use this upper and square root, it will be 2.645 multiplied by price root square root from current price, it will be 2, and divide for subtraction of these values, and then calculate this, and we have 41,000. It calculate liquidity 1, then we calculate liquidity 2 for y, for this formula, for this y will be equal liquidity multiply by square root from price upper minus price lower. And we can see that we have 20,000 y, yeah, divide by 2, it's square root price current minus 1.414, it is square root from lower price, and we have 34,129. Yeah, so we choose from these values. Minimum obviously it is 34,000, and we recalculate amounts next. We must recalculate amounts which we took from user. because we remember that in future we must do this because we have routing troubles and we must cut from this value some assets of this token, and you must provide liquidity in equals values for green sector and for blue sector. Okay, so we have a test from Uniswap book. It test right from Ivan Kuznetsov, and he do this in Python. So yeah, I just copy its code and do some changes. I just assign new prices and I just define new values, and we can run this code and receive answer. And in answer we can see that price range, current price, square root price low, current upper, yeah, and yeah, here we see that we can see liquidity 34,000, yeah, but it is just not here equal full because of rounding, I think. And we know that from user we must take token 0,4166 and token 1 90,999. So these assets will create liquidity in 34,142. It's not a big deal that these numbers not equal full. Calculation are right. Okay. Okay. What we do next? Let's try swap. So we provide liquidity. From book. You can read that Uniswap v3 store information about price in specific format, because price has fractional part. And recalculating token amounts. Yeah. So we're done with liquidity. Let's move to the swap. let's move to the swap. In book, he swapped 42 USDC. I, for example, swap 3000 of token 1. So user put in pool 3000 token 1. I just maybe delete this, and I have place to draw further. So we have first swap. Okay. Which formulas we need for calculate token amounts? We understand that here token 1 it is y, so delta y will be 3000, yeah, and we for swap we use this formula. This we can say that delta y will be equals to liquidity multiplied by delta square root from price. Yeah, but here we must find delta x. Delta x, it will be token 0 out. Delta x. So we must no, we must use these formulas again. This formula, because we can delta y, yeah, and from delta y we can find delta square root from p. When we put to the pool 3000 of tokens 1, price go upper, and we create new point P R, price R. We have in pool 20,000 of token 1, and now that delta y will be 3000, and we know that for PA y new will be 23,000. So first of all we must find delta square root from price. Delta, this means that it's difference between current price, between current square root price and square root from price A in point PA. And we can do this by this formula: delta square root price equals to delta y divided by liquidity. And we can see it's here, and we calculate this information. Why we do this? Because from delta square root p, from delta p, we can retrieve p target. We can retrieve PA, price. So if we use this formula, we must understand that delta y 3000 and divide by liquidity which we provide. I use this value which I receive from my calculation, not from calculation Python. It's not very important. Okay, it will be square root price. Next we must retrieve square root p. How we can do this? Simply because square root, because which is what is delta square root p? It is p current minus p target. Just do algebraic actions and we can say that p target will be p current plus delta square root p, and we can say that it will be 2.0879, and then we know this p target PA, and in book it's not in some picture we use PA, in other we use P target. In our example it is delta, it is square root from price in point PA. Okay, we have this value, and then we can put this value in this formula and this formula and calculate delta x. You can see delta x will be equals to liquidity multiply P target. In book this formula says that it's square root from PB, but it will be more convenient, more understandable if it will be P target. So it must be liquidity multiplied by P target minus P current divided by P target, square root from P target, and multiply on square root from P current. Okay, and we have from this equation value of delta x, so we can calculate delta x here, and it is value of token 0, which will be which user will receive from put from swap. So if user sell 3000 of token 0, he will receive 718 token excuse me, 3000 token 1, yeah, and he will receive 718 token 0. Okay, and we can calculate how many token 0 will be in pool in this case. Yeah, it is first swap. In this swap we swap token 0, token 1 for token 0. We move price to the left, we move price to close to the upper point, and we can calculate price simply just add power of 2 to this value, and we can receive price for point PA. I hope you understand it. It was first swap. Let's move further and let's implement second swap. I try do it more quickly, but I think main info understandable. So we have now P current equals to here, and we still have 23,000 of token 1 and 4,282 of token 0, and user sell 3,000 of token 0. In previous case, user sell 3000 of token 1. In this case, we sell 3000 of token 0. And we just use this formula again and calculate. Yeah, we know it's square root from price current. Next, we use this formula for delta x. This formula. And from that formula we retrieve delta 1 divided by square root from price. You must understand that this is delta before division. So we must create this calculation for retrieve per target. So all these actions we need for retrieve per target in this case and in previous case. First of all, we need per target, and we can do this because we know delta x. In our case, in second swap, delta x also will be equal to 3000, and square root from p target will be equals to 1.7667. And here we must understand that pool in production and I don't know, in first milestone maybe 2, code in Solidity is compare p target with square root p lower. Yeah, because if this price, target price, something here, will be lower than p lower, then we have problem. Maybe swap is completed partially, maybe it reverted full. I don't know. I learn Uniswap v3 still, and I don't ready to give you answer, but we have problem. And if this p target will be lower than square root p lower, in our case it fine, this comparison good, p target more than p lower, and we proceed with swap. Next we calculate from we use p target and simply goes to this formula delta y and calculate it. We have p current and P target, and we remember that P target 1.7, and we have here liquidity multiplied by P current, we know it from beginning, and subtracting P target square root, and we receive delta Y. It will be equal to 10,962, and these amounts of token 1 will be sent to user for his 3000 of token 0, and we can calculate new Y. So we can see that new X will be new reserves of token 0 will be 7,282, and new reserves of token 1, it will be 12,000. Okay, it was second swap. It was second swap, and we can see how work Python code from book. I change some info to swap. In our case we swap 3000, and we can see that we must send to user 718 of token, and it was first swap. It works correctly. Okay, and I think it will be useful to see how we can go lower than our P lower price. If user in this case won't swap not 3000, not 3, but if delta X will be 9000. If delta X will be 9000, if user won't swap 9000 of token X, what delta Y will be? In production, if this position is bounded for this P lower price, it's simple, just price move to another position and swap will end successful. But in our case we don't have another price positions, and we have only one price position, and we can calculate swap, and we can see that P target will be lower than square root from P lower. So we must, if we proceed with this P target, we can calculate delta Y, and it will be 25,000. but in our pool we know that T1 it's reserves of our assets, it's reserve of token 1, and we can see that we have only 23,000 of token 1, so we can't give user 25, we only have 23. So in our case it will be maybe partial, maybe swap revert all, I don't know, but it's trouble, it's trouble. So I think it enough for first milestone. It's very important to understand how it works in mathematics and the logical part. Implement this information, this logic in Solidity, just technical. It's not just so difficult. Okay, I think it will be enough. Thanks for watching. Bye.